Of the grade 9 academic math course, first section, angle relationship and triangles. This I expect to be some good review for you. Hopefully nothing new, but if it is, I think either way it's not that difficult. And because it's so easy, Charlie's really excited about it, not because he likes triangles that much. So what we're hoping by the end of today is that you can apply rules of interior and exterior angles to find them in a bunch of different situations. That's the goal for today's lesson. And I expect you're starting to write down, what is an interior angle, what is an exterior angle. If you look at the bottom of your page, you'll see a diagram of what I mean. But when we say interior angle, it's can be anything. It doesn't have to be a triangle. We're dealing with triangles today, but they're just the angles on the inside. All the different angles that you see on the inside of a shape. When I say polygon, pretty much just a shape, besides maybe a circle, and meaning a vertex. Exterior angles, they're a bit harder, but again, if you look at the picture, you'll see they're not that, what they are. But if you extended one of the sides and you measured the angle on the outside, that would be the exterior for outside. And we'll just switch to the next page. If I'm going too fast, of course, you can pause the tape. So vertex, actually first let's look at the picture here. So here's our triangle. All of these represent interior angles, right? All these ones on the inside. And then the exterior is if I extend this line past and measure this angle right in here, from here to here, that's an exterior angle. Here's another one, and here's another one, okay? Anyways, moving up. So a vertex is just the points. So every single point on a triangle or any other shape. There's a vertex, there's a vertex. Plural is vertice, by the way. And a polygon is just any closed figure. So if I use the term, or you see the term polygon, it just means it could be a triangle, it could be a square, it could be anything, okay? Any of the shapes that I know you've learned in previous math courses. Okay. So the rules related to interior angles is just that if you add up the angle in a triangle, this is specific to a triangle, if you add up the triangle, interior angles in a triangle, this one plus this one plus this one equals 180 degrees. So 3 angles add to 180. They're not necessarily all 60 degrees, 60, 60, 60, depending on the shape of the triangle. If it's equilateral, which means that all the sides are the same length, then it is 60 degrees, every single one. But that's not always the case. The rule with exterior angles is that this exterior angle here, if I take this one right here, is equal to the sum of the other two, interior. So that means that this one right here is equal to the sum of this one, interior angle, and this one. Okay? So we'll see an example to show you exactly what I mean. But this exterior angle here will be equal to the sum of this interior angle plus this one, the ones that are opposite it. Okay, so just to look at the example then, if we want to find angle A, and we know angle C is 70, angle D is 30, and we don't know angle B, but we want to find angle A. And based on the exterior angle rule we learned, we can say that A is equal to these two, C plus D added up. So that means A is going to be 70 plus 30, or 100 degrees. Easy, okay? Just one other little thing that I wanted to show you that's another, you might not know, or you might remember, you might not, is that anytime you have a straight line like this whole straight line represents 180 degrees. Okay? And so that means that B plus A, angle B, plus angle A equals 180 degrees. Okay? So that's just another little rule you can keep in mind when solving systems of triangles or anything else where you have a straight line like this. Anytime you have a straight line and then it's obviously broken up into two angles, the two angles will add up to 180 because the full thing, a straight line, represents 180 degrees. Okay? Just one more example, and don't jump ahead too much on the writing. These lines here indicate that these lines are the same length, which makes this an isosceles triangle. Okay, so if it's an isosceles triangle, one rule you probably learned in elementary school, if these two sides are the same length, then these two angles are equal to each other. Okay? Not the one that joins them up at the top, but the two down here. So if I want to find out, angle X. Well, if I use the exterior angle rule, I need to know A. Right? I know 20 already, but I need to know A to do that. And here's how you do that. So based on the interior angle rule, we know that these three angles have to add up to 180. Right? So A plus B plus 20 equals 180. Well, the thing is, since A and B are equal to each other, because it's an isosceles triangle, I can say, instead of writing A plus B, I'll write A plus 20 equals 180. I'm just substituting in A for B. And that means that 2A plus 20 is 180, subtracting 20 from both sides, right? So 2A is 160 or A is 80 degrees. Okay? Then I can say, all right, then X is the sum of these two. So X is A plus 20, X is 80 plus 20, so X is 100 degrees. Okay, so if you have any questions about that, please make a note of it now so that you can ask me next time we're in class. And otherwise, just go ahead and you can try a few of the homework problems. You can wait till you get to class tomorrow.